Hi everyone, welcome back. Today we are going to see about the electro-dynamo type wattmeter. So the purpose of instrument, ammeter which is used to measure current, voltmeter which is used to measure voltage, and wattmeter which is used to measure the power. So here we are using the wattmeter for the measurement of power. So the power, in general, the power is defined as the ability or capability to do something or act in a particular way. So here the power which is equal to the product of voltage and current. On wattmeter is used to measure the electrical power. And this is the wattmeter. There are three different types of wattmeters are there. One is electro-dynamo type wattmeter, induction wattmeter, and electrostatic wattmeter. Okay, so a wattmeter is the combination of ammeter and voltmeter. That is nothing but it has the wattmeter. It has two types of coil. One is nothing but current coil. The ammeter it contains current coil that will be presented here, and in the voltmeter it has then potential coil that also presented in the wattmeter. So the wattmeter consists of both current coil as well as voltage coil for the measurement of power. So therefore, the operating torque is produced due to the interaction of fluxes on account of current in current coil and voltage in voltage coil. So this is the dynamo type wattmeter. So here the scale is there, needle is there, pointer is there, and here FC. There are two FC. FC is nothing but fixed coil. FC is nothing but fixed coil. That is nothing but current coil. And single current coil is split into two parts. Okay, and single current coil is split into two parts. Okay, the current coil is always fixed. It not gets movable. And MC is nothing but moving coil. It is nothing but an voltage coil. Okay. So this electrodynamo type wattmeter, okay, now the source, the supply voltage is there. There are two fixed coil. That is nothing but fixed coil is nothing but current coil. So the single current coil is split into two of and in between the two of current coil, in between the two of current coil and moving coil is connected. The moving coil is nothing but an voltage coil. The voltage coil is connected across the source. The voltage coil is connected across the source, or it may be across the load. But the current coil and load are connected in series connection. Current coil and load are connected in series connection. Now if the switch is closed, the current is flowing through the current coil. After that it goes to the load. So how much amount of the load is consuming. Okay, now so the current drawn by the load which is flowing through the current coil alone. So the current coil gets energization, and the voltage coil is always energization because it is always connected across the source. Okay, now the current coil, it has only less number of turns and thick wire. Why it is less number of turns? If it has more number of turns, there may be more amount of losses across the coil. So in order to reduce the resistance value in the coil, which is not to oppose the current, we are reducing the number of turns, and the thickness of wire gets increased because R is equal to rho L by A. If the area gets increased, if the area is increased, resistance will be decreased. So the current coil, it always less resistance only, so that only the majority of current is directly goes from source to load. So the current coil is less number of turns and thick wire, which is help to maintain the low resistance. But in the moving coil, or maybe in voltage coil, it has more number of turns and very thin wire, because if the voltage coil has more number of turns, the resistance is high, and as well as it has less number of, and as well as the thickness is less. If the area is less, the resistance will be high, so that the moving coil it having high resistance value. So according to the current division rule, the current which is coming from the line, it not diverted into the voltage coil. So without diversion, all the current, the 99% of current which is supplied through the current coil into the load, so that the meter does not consume any electricity. It consumes only something negligible amount of current alone. Okay, so this is the assessment. Power is whether it's a rate of doing work or rate of producing voltage or rate of generating current or the rate of overcoming frictions. Okay, and second one, in DC circuit the power is measured using ohm meter and galvanometer, ohm meter and voltmeter, ammeter and voltmeter, ammeter and galvanometer. So put your answer in the comment section. And these are the some calibrations. If you are using several days, several months, several year, the meter should be calibrated to give the accuracy value. And there are few error, observation error, some of the error will be occurred. So in order to avoid this kind of error, so every 6 months once we have to calibrate. And these are the pros and cons, the advantage and disadvantage. The scale of the instrument is uniform, high accuracy, but here the error may be occurred, and stray field may affect the reading of instrument. And this is the second assessment. A wattmeter consists of current coil and potential coil. True or false? In dynamo type wattmeter, the fixed coil is split into 4, 3, 2 or 1. Okay, and list the advantages of dynamo type wattmeter. So put your answer in the comment section, and these are the few references. Thank you.